So, when I say artificial intelligence, what pops into your head? A sci-fi robot? Some kind of super smart computer? Well, the thing is, AI isn't some far-off sci-fi dream anymore. It's here. And its story? It's not about cold, hard logic. It's actually this incredibly human drama, full of brilliant minds, impossible challenges, and yeah, some tragic twists. Let's dive into the human side of this amazing technology.
And believe it or not, you're already swimming in it. I mean, AI is everywhere. Think about this morning. Before you even had your first sip of coffee, AI had already been hard at work, quietly shaping your day in ways you probably didn't even notice.
You know that route your GPS gave you? Yeah, that wasn't just a map. An AI was churning through this massive web of data, live traffic, construction, even your own driving habits, to figure out the absolute best way to get you where you're going. It's like an invisible coordinator for thousands of journeys all at once.
Or how about this? Ever bought gas at a weird time or in a city you don't usually visit? That's AI working for you again. It's a huge part of how banks work, especially with fraud detection. A neural network literally learns your spending habits, and the second something looks off, boom, it flags it, keeping you safe.
And it gets even more serious. AI is basically becoming the ultimate doctor's assistant. It's managing medical records, warning about drug interactions, and get this, with machine learning, it can now spot some cancers on X-rays and MRIs just as well as a human doctor, sometimes even better.
So we've got this super powerful, invisible force all around us. But where on earth did it come from? Well, the answer isn't in some shiny, sterile lab. It's actually in the minds of these totally remarkable and sometimes tragic people from history.
You see, the actual ideas behind AI, they were around way before we had any of the tech to build it. We're talking about people whose minds were just so far ahead of their time, the machines just couldn't keep up.
So let's jump back to the 1800s and meet Ada Lovelace. Now, her dad was the famous poet Lord Byron. And in this kind of ironic twist, her mom was so scared Ada would be wild like him that she pushed her into this super intense education in math and science. Little did she know she was setting the stage for a totally different kind of revolution.
But here's where Ada's true genius really shines. She was working with his inventor, Charles Babbage, and she looked at his machine, and she saw so much more than just a giant calculator. She realized, wait a minute, this thing could manipulate any kind of symbol. Musical notes, letters, whatever. And that right there, that was the first spark of the idea of a general-purpose computer, the very soul of AI.
And this was the machine that sparked that idea, the analytical engine. I mean, look at this thing. It was a 5-ton monster made of 8,000 parts, all powered by steam. It's just wild to think her ideas were a whole century ahead of the technology.
Okay, fast forward 100 years. We're in the middle of World War II, and another brilliant mind is up against this huge life-or-death problem, breaking the Nazis' Enigma code, which everyone thought was completely unbreakable.
And that brings us to Alan Turing. Turing knew, hey, to beat a machine, you've got to build an even better, faster machine. So he and his team at Bletchley Park built the bomb. This thing was an absolute beast, an electromechanical computer that could just rip through billions of possible codes every single day. It was a total game changer for the Allies in the war.
But after the war, Turing's mind went somewhere else, somewhere deeper. In 1950, he wrote this paper that started with his mind-blowing question. I propose to consider the question, can machines think? See, he wasn't just asking if they could do math anymore, he was asking if they could actually think. And that question, it basically kicked off the entire field of artificial intelligence as we know it.
All right, so the final piece of this early puzzle, man, it comes from one of the most unbelievable stories in the history of science. Get this. There's this kid, Walter Pitts. At 12 years old, he reads this masterpiece of logic, Principia Mathematica, finds mistakes in it, and writes to the author, the world-famous Bertrand Russell, to tell him about them. Can you imagine? Later, he drops out, ends up homeless for a while, but he's so hungry for knowledge, he just sneaks into university classes anyway.
So, Pitts eventually connects with a neurologist, Warren McCullough, and together they have this absolutely massive breakthrough. They figured out that if you make a simple model of how neurons work in the brain, they either fire or they don't, it's a yes or a no, you could use that simple on-off system to build all the basic pieces of logic, things like and, or, and not. This was it. This was the birth of the neural network idea, the engine that powers pretty much all modern AI.
Okay, so all the big ideas are now on the table. The year is 1956. There's this summer conference at Dartmouth. They officially give the field its name, artificial intelligence. And right away, the whole thing splits into two rival teams with two very different ideas.
So, in one corner, you had what they called symbolic AI, or as some people cheekily called it, good old-fashioned AI. Their big idea was that you could create intelligence by just writing down every single rule for logic and reason you could think of. And in the other corner, you had the neural network folks. They were like, no, the better way is to build a machine that can learn like a brain, not just follow a giant list of rules.
At first, things looked amazing. People were getting so excited they were making these wild predictions, like we'll have a fully intelligent machine in 10 years. But it turned out that stuff we humans do without thinking, like just understanding a sentence or recognizing a cat in a photo, that was way harder for a computer than anyone imagined. So the hype just got way ahead of what was actually possible. And when the progress stalled, the money disappeared and the whole field just froze. They call it the AI winter.
So what finally ended the AI winter? What brought on the spring? Well, it was basically a perfect storm of three huge things happening at once. First, the internet. Suddenly we had this insane amount of data to train these systems on. Second, Moore's law. Computer power was just exploding, getting cheaper and faster every year. And third, a really clever new math trick called backpropagation, which finally gave researchers a good way to actually train these super complex neural networks.
So the AI spring finally arrives, and the field is just exploding with progress. But all this success brought up this really deep question they'd kind of been avoiding for decades. Okay, we're trying to build artificial intelligence, but what even is intelligence anyway? There's a great little story from the animal world that makes it super clear.
Okay, so check this out. On the left, you've got the Sphex wasp. It has this very specific built-in routine for laying its eggs. Here's the crazy part. If you mess with its routine just a little bit, like move the cricket it's about to put in its burrow, the wasp gets stuck. It'll just repeat the same steps over and over, completely unable to adapt. Then you have the octopus. These guys can solve complex puzzles, figure out how to open jars, steal crabs from traps. They're constantly adapting to new situations. One is totally rigid, the other is incredibly flexible.
And that difference right there gets to the heart of what we really mean when we say intelligence. I mean, nobody has one perfect definition, but most experts agree it involves these things: learning, reasoning, problem solving, and especially that flexible interaction with the environment, being more like the octopus and less like the wasp. That's what AI researchers are shooting for.
And this brings us to a really important distinction in AI today. Most of what we have right now is what you'd call weak AI or narrow AI. It's unbelievably good at one specific task, like playing chess. It's a super complex task, but it's still a rigid wasp-like routine. It can't take what it knows about chess and apply it to, say, checkers. The holy grail, the big goal, is strong AI or artificial general intelligence. That would be a machine that has that broad, flexible, octopus-like intelligence that we humans have. But here's the thing. As we get closer to that goal, a really weird problem is popping up. These neural networks that are so powerful today, they have millions, sometimes billions of connections. They're so complex that how they make decisions is often a complete mystery. It's a black box. They spit out the right answer, but a lot of the time, not even the people who designed them can tell you exactly how they got there. And that leads us right back to the biggest, most mind-bending question of all, the same one that's been hanging around since Ada Lovelace first dreamed of a machine that could do more than just crunch numbers. As we build these systems that can learn and adapt in ways that we don't even fully get, what are we really doing here? Are we just building better, smarter tools? Or are we actually on the brink of creating entirely new kinds of minds?